Hi everyone, today we're going to start the 5.1 to 5.3 study guide for our quiz. Remote learners, please remember that you're expected to take your quiz during your scheduled geometry period, as well as to log into my Google Meet. Alright, so the first 7 questions are all vocab terms. So in a triangle, a segment connecting the midpoints of 2 sides of the triangle is called a midsegment. Number 2, the circumcenter of a triangle is equidistant from the 3 vertices of a triangle. Number 3, the incenter of a triangle is equidistant from the 3 sides of the triangle. Number 4, the perpendicular bisector of a triangle all pass through the point called the circumcenter. Number 5, the angle bisector of a triangle are concurrent at the point called the incenter. Number 6, how many midsegments does a triangle have? 3. Let's scroll down. So explain how to determine if a line passing through the segment is a perpendicular bisector of a segment. There are 2 things we need to know. Number 1, that the line must be perpendicular to the other line segment, creating a 90-degree angle. And I drew a picture here. And we see that, if you see this marking here, that means that they collide at a 90-degree angle, meaning that they are perpendicular. Also, one line must bisect or cut in half the same segment it is perpendicular to. And we should see tick marks. These tick marks mean that those segments are congruent. So now let's do some math. For number 8, solve for x given that BD is equal to 5/2 x plus 4 and AE is equal to 6x plus 4. Assume B is the midpoint of AC and D is the midpoint of CE. All right, so if B is the midpoint of AC and D is the midpoint of CE, that means that this segment here is the midsegment. And this segment is parallel to the third side, which in this case is AE. Well, look at our picture. It is clear that BD is not congruent to AE. I'll say that again. Those 2 segments are not congruent. We can see that AE is larger. But how much larger is it? Well, it's double what the midsegment is. So if my midsegment is 5/2, sorry about this, plus 4, and my third side is 6x plus 4. If I wanted to set up an equation, I would need to multiply BD by 2 for it to equal the larger side AE. So let's write that out. So 2 times my shorter segment, which is 5/2 x plus 4, is equal to my larger segment, which is 6x plus 4. All right, so now I need to solve for x, so I need to multiply 2 inside the parentheses here, which gives me 5x plus 8 is equal to 6x plus 4. All right, so let's subtract 4 from each side. When I do so, I am left with 5x plus 8 is equal to, sorry about that, 5x plus 4, because I subtracted 4 from 8, and then is equal to 6x. So next I need to subtract 5x from each side, and when I do so, I end up getting that 4 is equal to x, and I am done. Let's scroll down for number 9. So in the diagram, DE, FE, and DF are mid-segments of the triangle ABC. If AB is equal to 12, BC is equal to 15, and AC is equal to 16, let's solve for x, y, and z. All right, so let's first start with x. I'm going to highlight x. FD is my midsegment, and AC would be the third side that it's parallel to. Well, if I look up here, I know that AC is equal to 16, so let's mark this. So if AC is equal to 16, what would the measure of FD be? Well, it would have to be half of AC, and half of 16 would be 8. So x would be equal to 8. Next, let's solve for y. So y is in this midsegment here, y plus 4, and the third side that is parallel to that midsegment would be AB. Well, if I look here, I know that AB is equal to 12. So this entire segment here then is equal to 12. Well, let's remember, how do these two compare? Well, my mid segment is half the length of the third side. So for DE to equal AB, I would need to multiply it by 2. So this would mean that 2 times y plus 4 would equal the third side, which we know is 12. Distribute this 2 inside the parentheses. That would give me 2y plus 8 is equal to 12. Subtract 8 from each side. I get 2y is equal to 4, which means that y is equal to 4. And lastly, let's solve for z. So my z equation is here. The third side would be the side BC, and I see here that BC is really equal to 15. So if EF is my mid-segment, it is half the length of BC, so I need to do something very similar that I did in for solving for y. So I need to multiply my mid-segment by 2. So 2 times my mid-segment, which is 1/2 z, is equal to 15. Well, if I multiply 2 by 1/2, I end up getting that z is equal to 15. And I'm done. Number 10, refer to the figure below. If BC is equal to 15, and I'm going to write this right away, what is the length of LN? Well, LN would be a mid-segment, and I see that because L is a midpoint and N is a midpoint because of these tick marks. And L is between those, and N cuts that in half. So if BC is 15, what would LN have to be? Well, 15 divided by 2, which is equal to 7.5. Part B, if AB, let's highlight this, if AB is equal to 3x plus 5, so let's label this, and MN, which is this here, is equal to 2x plus 1, we want to figure out what is the length of NM. All right, well, NM is our mid-segment, and we know that because N is a midpoint, M is a midpoint, and when you connect two midpoints, we have a mid-segment. So how does MN compare to segment BA? Well, it would be half. So to make MN equal to our segment AB, we would need to double it. So let's do that. So I'm going to do 2 times 2x plus 1 would equal the large third segment, which is 3x plus 5. All right, so distribute. I end up getting 4x plus 2 is equal to 3x plus 5. Let's subtract 3x from each side. This leaves me with x plus 2 is equal to 5. Subtract 2 from each side. X then is equal to 3. But remember, I'm not done because it asked me to solve for NM. So let's plug 3 back into my equation for NM. So that would be 2 times x, which we know x is 3, plus 1, and that is equal to 7. All right, next, NO is perpendicular bisector of segment LM. If OM is equal to 4 and LN is equal to 6, then LO is equal to what? And MN is equal to what? All right, so let's label what we know. So since NO is a perpendicular bisector, we have a 90-degree angle here, and we know these segments are congruent. We also know that if this is a perpendicular bisector, N is equidistant from points L and M. So I can also set these equal to each other. Well, we know that OM is 4, so this segment here is 4, and LN is equal to 6. So LO would have to equal what? Well, LO would also have to equal 4 because O is a midpoint. It's right in the middle. So I'll label that. And MN, oops, sorry, and MN would have to equal 6, because once again, point N is equidistant from our 2 points L and M. So this would equal 6. Given that ray AE bisects angle DAB, we want to find ED if BC is equal to 15 and CE is equal to 36. Please note that the drawing is not to scale. All right, so let's label what we know. So we know that AE bisects angle DAB. So DAB is this angle here. So that means that DAC is congruent to CAB. These two angles are congruent. I also know that BC is 15. So BC is this segment right here. I will label this as 15. And CE, which is this segment right here, is equal to 36. And they asked us what is the length of ED. Okay, so ED is right here. This is X. Well, let's remember, if this is an angle bisector, okay, we know that these two segments are the same because E would be equidistant from point D and B. So if DE is X, we know that EB will also be the same length, which I'll call X. Now, if you look, I have a right triangle here. So I'm going to redraw my right triangle. Have my 90-degree angle. X is the hypotenuse. I know this segment is 36 and this is 15. So remember, this is not drawn to scale. All right, so to solve for X then, I need to use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. So a, I'll call 36. So 36 squared plus b, which is 15, is equal to our hypotenuse, which in this case is x. All right, well, 36 squared is 1,296 plus 15 squared, which is 225, is equal to x squared. Combine these together, I get 1,521 is equal to x squared, but I don't care about x squared, I care about x. So to get x by itself, I need to do the square root of each side. So the square root of 1,521 would give me 39. And I'm done. All right, next I have a multiple choice question. So if ray OE bisects angle BOA and segment AE is perpendicular to segment OA and EB is perpendicular to OB, which statement is not true? Okay, so let's look at our diagram. Is AE congruent to BE? Would these two be congruent? That is yes, so that's true. Is angle AOE congruent to angle EAO? Well, let's look at those. AOE. AOE would be this angle here. And angle EAO, I'll highlight in blue, so this angle here, are those congruent? Well, that is not true. So this is going to be our answer here. We see that EAO is a 90-degree angle, and angle O, we don't necessarily know that well, actually, it couldn't be a 90-degree angle. Okay, it's got to be something less than 90 degrees. So answer B is correct here. It would not be true. In the diagram, X is the incenter of RTV. We want to find UX. All right, so if this is the incenter, we would know that these segments are congruent. Well, that doesn't really help us with this problem what's going to help us with this problem is that we have a right triangle, and we want to figure out what x is. So we're going to need to use that Pythagorean theorem. So remember that a squared plus b squared is equal to c squared. Our hypotenuse in this case would be 13. So we'll call a x. So this is going to be x squared. Plus b will be 12. So plus 12 squared is equal to 13 squared. Let's simplify this. So x squared stays as x squared. 12 squared is 144. And 13 squared is 169. So I'm going to subtract 144 from each side, which gives me x squared is equal to 25. But I don't care about x squared. I want to figure out what x is. So I need to square root each side, and that gives me that x is equal to 5. All right, so let's scroll back up. Well, we wanted to figure out what's the segment of xu. Well, xu is this segment here, which means it's also equal to x, and we solved that x was equal to 5. And I'm done. And for our last problem here, we want to solve for x. All right, so if I look at this first diagram here, I notice that these angles are congruent and these are perpendicular, which means I have an angle bisector. If I have an angle bisector, this point is equidistant from these points here, meaning that those two segments are congruent. So to solve for x, I just need to set these two equations equal to each other. So x minus 3 is equal to 21. I'm going to add 3 to each side. So x is equal to 24. And for my last problem here, I notice that I have a 90-degree angle, as well as that those segments are congruent, meaning this point is equidistant from those 2 points, meaning I have an angle bisector. So to solve for x, I need to set those two equations equal to each other. And I get 3x is equal to x plus 20. Subtract x from each side. 2x is equal to 20, meaning that x is equal to 10. And I'm done.